Hey guys, welcome back to my channel. So this is lighting class 3, and before watching this class, please watch class 1 and 2. They are completely based on concepts and formulas which will help you solve this. Okay, so let's start with the first problem. It's from GATE 2019. The illumination level of a room is 300 lux and the efficiency is 60. Okay, so they have given illumination E, that is 300 lux, that is nothing but 300 lumens per meter square, right? Then they have given the efficiency is 60. So efficiency is equal to 60. We know the units. Efficiency is lumens per watt. Okay. The light power density of the room in watt per meter square is. So light power density is nothing but lux divided by efficiency, that is 300 lumens per meter square divided by 60 lumens per watt. Okay, so lumen gets cancelled, watt goes into the numerator, it's 5 watt per meter square. Okay, so for solving these questions you must be completely aware about the units. Okay, so sometimes if you forget the units, just look at what's asked in the question, and by simply playing with multiplication and division you can arrive to the units and indirectly to the answer, right? So be well versed with the units first. I hope you are pausing the video before start of each problem and try to solve by yourself. Okay, this will just increase your understanding of the question. Okay, so carrying out with next, the indoor illumination requirement of a building is 350 lux. Okay, so consider there is a building, okay, and the illumination requirement is 350 lux, right? The daylight factor is 2.7 and the sky illuminance is 9000 lux. So there is sky outside, this illuminance is 9000 lux. The required artificial supplementary lighting is dash lux. See, 350 is the requirement, okay, but currently the current 350 is not satisfied. Okay, there is less lighting inside, that's why we need additional supplementary lighting. Okay, so in order to find how much lighting we are deprived of, we have to find the current illumination inside first. So daylight factor is given by EI divided by EO into 100. So first we have to find EI, the current illumination inside, then only we can see how much artificial lighting is required. Okay, so EI is DF into EO divided by 100, that is 2.7 into 9000 divided by 100. Okay, so 2.7 into 90 is 243 lux. Okay, but the requirement is 350 lux, so the additional supplementary lighting is 350 minus 243, that's 107 lux. Okay, I hope you understood this question. So there was some sort of less artificial lighting, so we need 107 additional illuminance inside to meet the requirement of 350 lux, right? Let's carry on with the next question. This is a match the following. I know you all are very efficient to solve this one. Please solve it and let me know in the comment section. You can match these options. Okay, PQRS with 1 2 3 4 5. Carrying out with GATE 2017. Pause this video right now, try to solve by yourself, and then you can continue watching. A fluorescent light consumes 40 watt electrical power. So there is a fluorescent light whose power consumption is 40 watts. Okay, and has an efficiency of 40 lumens per watt. Okay, so illumination in lux at a distance of 3 meters from the light source. Okay, So this distance is 3 meter. We need illumination at this level. See, now this light, the fluorescent light, gives 40 lumens of flux in consumption of 1 watt. Okay, so for 40 watts consumption, how much lumens it will give? Yeah, you are right. It's 40 into 40. That's 1600 lumens. So this is the flux output of the fluorescent light, right? So for 1 watt, it gives 40 lumens. So for 40 watt, it gives 1600 lumens. Okay. Now we have to find lux at 3 meter distance. So E is equal to flux by meter square. Okay, flux we have 1600 lumens divided by 3 square, that is 9. Okay, this is 3 square. Okay, distance ka square, 3 meter ka square is 9. So this is 1600 divided by 9, that is 177.77 lux, right? So before solving any question, draw a simple basic diagram through which you can understand better, and then solving becomes easy. So now this problem is from GATE 2016. A lamp source of 3200 candela is mounted on a ball. See, it's mounted on a ball at a height of 2 meters from the work plane. So there is a work plane, there is a wall. This light is mounted here at a distance of 2 meters from the work plane. Okay, it subtends an angle of 60 degrees with the center of the work plane. Okay, so consider this point as center of the work plane. So this angle subtended here is 60 degree. Okay, the illumination at the center of the work plane is dash lux. So illumination here they have asked. So let's name this point as A, B, C. AB is the wall. Okay, C is the center of the work plane. Consider distance AC as R, denoted by R. Okay, so we know the formula E is equal to I by R square cos theta, right? So in order to find R, we have to use cosine of angle. So cosine of 60 degree is adjacent by hypotenuse. Okay, so this R is hypotenuse, cos 60 is equal to adjacent upon hypotenuse, that's 2 by R. So R is equal to 2 divided by cos 60, that is 4. Okay, so this is 4 meter. So R is equal to 4 meter. So simply substitute in this formula. So I we know 3200 candela, R square is 4 4s are 16 into cos 60 degree, right? So 3200 divided by 16 into cos 60, which will give me 100 lux, right? So the illumination at center of the work plane is 100 lux. Okay, so see how drawing a figure can help you solve this question. Okay, so for not only lighting, for every concept, try to draw a figure. Okay, so carrying out with class 2015 problem. A classroom measuring 10 into 8 into 2.7 length into breadth into height requires an illumination of 500 lux. E is given as 500 lux on the desk level using 40 watt fluorescent lamps. So there is 40 watt fluorescent lamps rated at an output of 5000 lumens each. Okay, assuming utilization factor as 0.5 and maintenance factor as 0.8, the number of lamps required is. So there is an work area. Okay, that's 10, 8, and the height is 2.7. Okay, this height is 2.7. So there will be a volume formed. Okay, 2.7. So requires an illumination is 500 lux. We have E is equal to 500 lux. Okay, there is 40 watt fluorescent lamps with rating output of 5000 each. So each lamp has an lumen output of 5000 lumens, right? So they have given UF and MF. Now number of lamps they have asked. We know the formula, number of lamps is equal to lux into area divided by lumens output of each lamp. Okay, lumen output of each lamp into UF into MF, right? So lux is given as 500 requirement, area is the plane area, okay, that is 10 into 8 divided by lumen output of each is 5000 into UF is 0.5 and MF is 0.8. Okay, so solving this you will get the answer n is equal to, so 500 into 10 into 8, that's 40,000 divided by 5000 divided by 0.5 divided by 0.8. So you will require 20 fluorescent lamps to light this classroom for 500 lux, right? So simply apply the formula and you will get the answer. So these are the easy questions. These are the scoring questions. So never keep lighting as a choice, okay? Be prepared, it's very easy. See now this question, flux emitted by one candela light source in all direction in lumens would be F is equal to 4 pi I. I is given as one candela, 4 pi is the steradian angle. So F is equal to 4 pi I is equal to 1, F is equal to 4 pi. 4 is pi is nothing but 12.56. So flux emitted by this is 12.56. okay, see these are the basic questions, very scoring questions. This topic is very scoring. Link question 54 and 55. See in previous GATE papers like 2013 there were linked questions, okay? So if you get the answer for one, substitute that in second question and you will get the another answer also. So these types of questions were very scoring during like 10 years, 7 years before. But now linked questions are not asked, okay? So a room of size 100 square meter is illuminated by 10 lamps of 40 watts having efficiency of 40 lumens per 50 lumens per watt. So the total flux emitted by the lamps in lumens would be, see we have 10 lamps, each has a power of 40 watt and an efficiency of 50 lumens per watt, right? So this will give me total power 5 4s are 20 onto 3 zeros. So effective lumens is 20,000 lumens, right? If the utilization factor is 0.5 and the working height is 90 centimeter above the floor level, illumination in lux would be. Now remember this concept, lux is equal to lumen per meter square or candela per meter square. In this lumen per meter square, this generally denotes area. In candela per meter square, this generally denotes square of distance. Distance ka square. Okay. Now they have given this working height of 90 centimeter just to confuse you. Okay, there is no need of this term because many students make this mistake. But actually it's the area that has to be taken. Okay, it should not be 0.9 ka square. That's wrong. It should be 100 square meter. Okay. So utilization factor is 0.5. Okay, which means we know formula for utilization factor, that is lumens on working plane divided by lumens emitted by light source. Okay, light source. So it's 0.5. okay, and light source ka lumens we know 20,000. So 20,000 into 0.5, that means this lumens on working plane is 10,000. Okay, sorry I went out of the screen. So UF is equal to, let me delete all this. We know UF is equal to lumens on working plane divided by lumens emitted by light source. lumens emitted by light source is 20,000, UF is 0.5. So working plane is 0.5 into 20,000, that's 10,000, right? Okay. Now we have illumination in lux would be. So lux is equal to this effective lumens on working plane, that is 10,000, and area of 100 meter square. So answer is 800, right? See, don't ever get confused between lumens per meter square and candela per meter square. This is basically the distance, like in GATE 2016 problem we saw, no? This problem, 60 degree wala problem. See, this is the distance where it was given in 3200 candela. See, candela per distance square give me the answer. But in this lumen per meter square, it generally denotes the area. This 90 centimeter is just to confuse you. Okay. So don't get tricked by the examiner in this type of questions. They basically want to test you, okay, how much you're good with the concept. So GATE 2012, I really want you guys to perform that good. Okay, so that's why I'm giving all this bhashan. And let's carry on. A painting in a living room needs to be lighted at 250 lux. It requires 250 lux. If the light is incident normally on the painting at a distance of 6 meter, incident at 90 degree normally, at a distance of 6 meter, the intensity of light source required in candela is, see, now we have requirement in candela, so it's distance, okay, it's not area, it's distance per square. So we have a light, okay, we have a painting here. Suppose the painting is on the ground, the light is incident normally at 90 degree, it's 6 meter, okay, and the painting is on the ground. The required illumination is 250 lux, right? So E is equal to I by R square. Okay, so 250 lux is equal to I. We have to find the light source ka candela, and R square is 6 ka square, that is 36. So I is 250 into 36, 25, 36 into 250 will give me 9000 candela, right? So candela per meter square ka meter square is distance, lux per meter square ka meter square is area. Okay, don't ever confuse. So now GATE 2010. In a display of window height, h is equal to 8.66 meter. So this height is given, h is equal to 8.66 meter is a display window of a retail store. So this is a retail store, its display is height 8.66. A luminaire of intensity I is mounted at a distance of L is equal to 5 meter away from the rear. So L is equal to 5 meter away from the rear. Okay, so this is 5 meter, this h is 8.66 meter. Okay, so its light beam is cast at an angle of 45 degree from the ceiling as shown in the figure. 45 degree from the ceiling as shown in the figure. The ratio of illumination at point P1 and P2 is. Okay, so see, this is a very logical question. Okay, very good question. The ratio of illumination of point P1 and P2 is, see now, point P1 is closer to the light source, point P2 is far away from the light source. Though illumination at P1 will be always greater than illumination at P2. Okay, so this ratio should be greater than 1, right? Logically this ratio should be P1 by P2 should be greater than 1. Okay, because the denominator is smaller, numerator is bigger. So by looking at the options, 1 by 2 is never an option because 1 by 2 is 0.5, it's less than 1. And 1 is to square root of 3. 1 is to square root of 3 is also not an answer because it's less than 1. So our answer is between B and C, right? So now considering this beam, okay, considering this triangle SOP1, and considering triangle SOP2, we have to find the distance, right? This distance we have to find. So SP1 we will get by applying laws. This is 45, this is hypotenuse, we know that. So cos 45 is equal to L by SP1. Okay, similarly here cos 60 is equal to L by SP2. So L is equal to 5, here L is equal to 5. So SP1 is equal to 5 into cos 45. 5 into cos 45 is, am I right? No, SP1 is equal to 5 divided by cos 45. Yeah, 5 divided by cos 45, that is 7.07, right? And here SP2 is equal to L divided by cos 60. Okay, so 5 divided by cos 60, it's 10. Okay, so it's 10 meter. So this one is 7.07, this is 10. Now we have to simply apply the formula E is equal to I by R square cos theta. Okay, so considering at point P1, E is equal to I. Intensity will always be the same at 2 points. Okay, E is equal to I by 0.07 cos square into cos 45. Okay, E at P1 and E at P2. I by 10 cos square into cos 60 degree. So I gets cancelled. This ratio is cos 45 into 100 divided by 7.07 cos square into cos 60. Okay, so this answer is 100 into cos 45 divided by cos 60. Okay, cos 60 divided by 7.07 square, that is 2.829. Okay, 2.829 is the ratio of illumination. Square root of 3 is to 2. Oh no, this is not the answer. Similarly, square root of 2 is to 1. This is not the answer. So this problem typically has no options in the answer. So this was the correct option. Okay. See, for this type of questions, they will give 2 marks. Okay. If you have basically attempted the question or your answer is anywhere between the range. So there will be a range of options in the gate answer key. Okay. So if your answer is in between that range, you will get 2 marks. Okay. So carrying out with next question. This is the last one. It's a linked question. Okay, so it's easy. A room measuring 10 into 10 meter has to be illuminated by 200 lux by a single electrical lamp. See, there is only one electrical lamp. UF is 0.75, MF is 0.8. So the lumen output of the lamp, we know number of lamp 1 is equal to lux. Lux is 200 into area is 10 into 10. Okay, divided by, we have to find the lumen of this single lamp into 0.75 into 0.8. Okay, so for finding lumens, 200 into 100 divided by 0.75 divided by 0.8. Okay, so it's 33,333. So this is the answer. So depreciation factor of the above lamp is, depreciation factor is equal to 1 divided by it's a reciprocal of maintenance factor. Okay, so 1 divided by 0.8, it's 1.25. Okay, so df is equal to 1 by mf, that's 1.25. okay, so these were all the problems up till 2007. Okay, we have completed lighting also. So till now for numericals we have completed estimation, acoustics, lighting. See, 3 major topics we have covered. Okay, so start practicing, guys. Regular practice is a must. Okay, start practicing the GATE virtual calculator. Okay, so for GATE exam, online exam, there will be a virtual calculator available to you in the computer screen. It's not like the normal calculator, where in this virtual calculator calculations are little bit different. Okay, so start practicing this side by side for solving the problems. Okay, so thank you for watching this video up till end. Okay, take care, bye bye.